Okay, the next issue I'm going to talk about in data modeling for data warehouses is granularity, which basically means how detailed you want in your data warehouse. Okay, if we want a high granularity, that means we want more detail. Then that means that data is described by many characteristics. And on the other hand, low granularity means that we have fewer characteristics that are used to describe our data. Okay, and the higher the granularity, then we have more options in terms of query and reporting. Okay, we can drill down into more detail. We can slice and dice in more ways using different characteristics. So users will be happy if we have a high granularity, basically. Okay. On the other hand, if we have too much detail, then it's going to have a negative impact on the performance of query processing and load time. Okay, because we need to load more data into the data warehouse. So there is a trade-off, or there are techniques that we need to be aware of when the granularity is high in our data warehouse, which we'll talk about related issues later on. Okay. The first is related issue is the dimension cardinality issue. Okay, so for the dimension tables that we will create in our data warehouse. Okay, so after we talked about earlier that in our MERM model, the final goal is to form dimensions, right? So after you have identified all your dimensions, then the next thing to think about is if the dimensions are properly structured. Okay, in other words, do they have too high cardinality? Now, a rule of thumb shown here is that we want to make sure that, generally speaking, number of records in a dimension table is in the neighborhood of low 100,000. Okay, you don't want to have too many records in a single dimension, otherwise it's going to negatively impact the query response time. Okay, or another rule of thumb is that each dimension table should be about 10% of the fact table. Okay, because a data warehouse can grow in size very quickly, and I will give you a simplified example later on to show you how big a data warehouse can grow quickly. But again, in terms of dimension tables, we try to keep them at a manageable size. Okay. So the first bullet is talking about the some rule of thumb there. Okay. And what if you have more than 100,000 records? For instance, a large company can easily have raw materials or material number of products. Okay, and number of parts that they stock, or the number of employees, number of customers easily exceed 100,000. So if you have that kind of situation, they are known as high cardinality characteristics. Then we will model them as line item dimensions. In other words, a dimension with just a single characteristic. Okay, you don't want to combine that with any other characteristics to make it even bigger. Okay, so for those dimensions, for those characteristics, I should say, there are no separate dimension tables. Okay, they are known as line item dimensions because for those characteristics, a single dimension contains just one single characteristic, whereas in a regular dimension table you will have multiple characteristics. Okay, what is the relationship between customer and material in general? All right, so we've done with conceptual or semantic modeling. The next step is to go into logical modeling. Okay, specifically logical modeling for data warehouses using SAP BW. Then we are talking about developing models for basically two types of data. Okay, master data, and secondly, InfoCube data. Okay, or master data versus transaction data, because in your InfoCube you basically have transaction data. First, for master data, the data model. Okay, recall that we have three types of master data, or three possible types of master data in BW. Okay, so for each piece of master data, we are talking about customer or material or employee and so on. Okay, we can have attributes, tags, and hierarchies. Okay, so three types of master data, and each type is stored in a separate table. Okay, so in our data model, we have one table for attributes, another for tags, and another for hierarchies. Okay, and actually, three is the minimum. Okay, we may have, two hierarchy tables if we have, two separate hierarchies, and we may have, three different text tables and so on. Okay. Plus a surrogate ID or SID table. Okay, so surrogate ID is the key for the records, which we'll talk more about later on. Okay, so again, the basic idea is that we're going to have a bunch of tables for our master data. Okay, for your attributes, for your tags, for your hierarchies, plus a key table known as a SID table. But the good news is that all the tables will be created automatically by BW when we activate the info object. Okay, so if you're talking about customer master data, you create a customer info object, right? So after you provide all the information for the info object, you save it and then you activate it, and then BW will generate all the tables for you. Okay. Next, we talk a little bit about the separate tables for master data. First, for attributes, we have display versus navigational attributes that we have talked about before already. Actually, here again, display, we use discrete versus discrete plus scalar information, okay, such as the volume, the weight. But for navigational, we normally have discrete information, okay. And your attributes may be time dependent versus non-time dependent, okay. You can define attributes that are only valid for certain time periods, or they are valid, forever until they are changed, okay. Finally, also notice that for attributes, we can also use key figures. Okay, so that's not very common, but sometimes we may want to define additional attributes using key figures. For your text table, SAP BW has a separate text table to store names and short descriptions of key data. Okay, not key figures, but for your customers, for your products, you have product descriptions in English, in Spanish, in German, and so on. Okay, the reason is that we can improve performance, we can accommodate different languages, and again, we can also accommodate time dependency. Okay, we can determine a particular time period during which a description is valid, and so on. Okay, So we have a lot of flexibility by having a separate text table. Hierarchies recorded in the hierarchies table or tables. There are all kinds of hierarchies we can use. Okay, internal hierarchies are modeled in attributes. Sometimes we have a natural hierarchy to classify our employees or our products or whatever. Okay. For instance, even at a university, we had, for instance, different types of students, as we can all relate to. We have graduate students, we have undergraduate students. Okay, so we have some kind of hierarchies right there, or classification. Okay, so we can model that as part of the attributes. So for each student record, we can have an attribute or a field that says classification. So right there we can tell whether a student is undergraduate student or graduate student based on that hierarchy information, okay, as part of the attributes. Says here useful homogeneous balanced hierarchies such as customer groups, employee groups, product groups, and so on. Okay. External hierarchies, on the other hand, they are stored in separate hierarchy tables. Okay, they are normally used for heterogeneous, unbalanced hierarchies. So now we have lots of flexibility, different ways that we can classify our products. A lot of companies have all kinds of ways to classify their products in using different attributes and so on, and some of the classifications are unbalanced. Okay, you don't always have the same number of nodes on a particular level of the hierarchy, for instance. Okay, but it doesn't matter. And a lot of times those hierarchies are stored in the production system. Okay, in SAP or ECC, for instance. And we can simply import those hierarchies from ECC into BW, so that now we can classify our products, for instance, using those hierarchies that are stored in a separate hierarchy table. Finally, for each piece of master data, we have a separate SID table. Now, says here that it consists of two fields. Okay, one is surrogate key generated by BW, and two is a real world or semantic key. Okay, so in the real world, depending on your company, you might have a 9-digit number for customers, for instance. Okay, or 10 letters for your products, whatever. That's okay. You can use whatever keys you've been using for your business. Okay, but for each record that you import into BW, BW will generate a surrogate key. Okay, a system key or surrogate key to match with the real world key. Okay, and there are some very good reasons for that. One of them is shown at the bottom here is that the SID then provides the link between master data, for your custom master or product master and so on, and transaction data which are stored in your InfoCubes. Okay, and we'll see some examples later on. But that just keep that in mind, that SID table is critical to the success of BW because it provides a link between master and transaction data. And on the next slide, I actually have a sample, a screenshot of SID table that you can actually look at in BW. Okay, this is the SID table for material. Okay, this is a sample material table that comes with BW. as you can see, it actually has more than two fields or two columns. Okay, but for our purpose, we can just think about that it has two. Okay, one is a material ID, which is the first column or first field. Okay, so for each material ID that we use in the real world, okay, let's say 100-100. Okay, BW has generated a SID. Okay, in this example, SID 12, and for the next material, SID 13, and the next one, SID 14, and so. Okay. So again, SID is generated automatically by BW for each real-world key that we import into our master data table. Okay. Okay, a review question about the SID table.